Dear students, have a nice day. In previous class we have seen chi-square test for goodness of fit. So this testing is also used to analyze whether two attributes are dependent or independent. Let's move on to the topic. Now you can see a table. This table representing the given observed frequencies. These frequencies are arranged in matrix format. So here the data are arranged in row wise as well as columns. So the columns representing the frequencies corresponding to attribute A, and the rows representing the observed frequencies corresponding to attribute B. Here the last column represents the row wise totals corresponding to each of the elements in the rows, and in the last row represents the column totals, the total values for each of the columns. And this capital N, it is nothing but the sum of all the observed frequencies. So either you can add the last column values or the last row values, so that both the values should be equal. So the above table, it is known as S cross T contingency table. Here S represents number of rows and T represents number of columns. That N we have already seen, that is the sum of all the frequencies. Oj, that is representing the observed frequency corresponding to ith row and jth column. So it is a cell frequency also we can represent, ijth cell. Now we have to find the respective expected frequencies for each of the cell values. So here you can see the formula corresponding to that Eij. For the ith row and the jth entry, the respective Eij value can be calculated using the formula. The respective row total value and the into the respective column total value divided by the grand total value. So I can say it's the product of row total and the column total with respect to the grand total value. And the degrees of freedom for this S cross T contingency table is nothing but S minus 1 into T minus 1. That is, you can say the product of number of row minus 1 and the number of columns minus 1. So for now, here you can see this is a 2 cross 2 contingency table with the entries are row entries A and B, and the second row entries are C and D. Now using this chi-square formula for 2 cross 2, you can get this value. Sum of all the entries, that into AD minus BC the whole square, is divided by the row total values as well as column total values, the product of all these values. So you can get chi-square value for the 2 cross 2 contingency table. Now let us see one example problem. See this problem. An opinion poll was conducted to find the reaction to a proposed civic reform in 100 members of each of the two political parties. The information is tabulated below. So here the data are given for two different parties under three different attributes: favorable, unfavorable and indifferent. The values corresponding to party A are 40, 30 and 30, and the respective values for party B are 42, 28 and 30. Test for independence of reduction with the party affiliations. Now you can see the solution. So for any type of testing problem, the first initial step is to set up the null hypothesis. So here you can see the null hypothesis. In most of the problems, we will take the attributes are always independent. So here also I have taken this null hypothesis. Reactions and party affiliations are independent. Now the expected frequencies can be calculated using this method. So here the datas are arranged in the given datas are arranged in matrix format. You can see this matrix has 2 rows and 3 columns. The last column represents the total of each of the rows, 100 and 100. The last row represents the column wise total. You can see that is 82, 58 and 60. And the grand total is nothing but sum of the last column or the sum of the last row, which is both equal to 200. Now next you can see this table. So using this table we are calculating the expected frequencies for each of the cell. For the first, consider the first row and first column element, that is E11. It is calculated as the first row total 100 multiplied by first column total 82 divided by the grand total 200. So the value is 41. So likewise you can calculate the rest of the values by using this, the respective row total into the column total divided by grand total. So we have obtained 29, 30 for the first row, and for the second row, that is E21 is 41, E22 29 and E23 30. So next step is to find the test statistic value, that is chi-square. You already know this formula, that is OI minus EI the whole square divided by EI. So here I have listed the given observed frequencies as well as the expected frequencies just before we have calculated. And either you can write the last column as OI minus EI the whole square divided by EI. So by calculating and finally getting the sum of all these values, you will get the chi-square value. That value is 0.116. For this 2 cross 3 table, the degrees of freedom is nothing but it is the product of number of row minus 1 into column minus 1. So we have 2 minus 1 into 3 minus 1, which is equal to 2. Now we have to find the respective table value for this degrees of freedom 2. So you can take your chi-square table and refer at 5% level of significance, see the table value corresponding to 2 degrees of freedom. It is 5.99. Now the calculated value we have, it is less than this table value. So obviously we have to accept the null hypothesis. So our hypothesis is accepted at 5% level of significance. So therefore the given attributes they are independent. That is, the independence of reactions with the party affiliations may be correct. Thank you.